what I'd like to do is see which one of these equations matches up with the slope field. I noticed that this is around 2, so at every x value where x equals 2, I find I have a slope of 0. So I'm going to plug in x equals 2 to each of these equations and see if I can't eliminate any right quick. So I take x equals 2, and notice 2 times 2 is 4, which is not 0, so it can't be choice A. Then I take x equals 2 and I plug it in. 2 times 2 is 4. 4 minus 4 is 0. It could be choice B. That might be the answer. I don't know yet. I'm going to take x equals 2 and put it in there. 4 minus 4, that's 0. So I notice I have a slope of 0. Slope of 0 everywhere along here. And then I'm going to plug in 2 there, but I need a y value. So I'll do it right here at 2, 0. So 2 plus 0 is 2. Not 0, so it can't be that one. Now I'm going to pick around this area. Now this scale isn't very nice. I mean, that's a 5. And this is 2, so it's not the scale. I always like to go to 1, 1, so... But notice, anywhere in this quadrant, it's going to be a negative slope. So I'm going to use 1, 1 to see if I can get a negative slope out of it. What's 2 times 1? That's 2. Minus 4. 2 minus 4 is negative 2. So it could be that one again with a negative slope. Let me plug this in. X value, 1. So 4 minus 2, that's a positive slope. So it can't be choice C. It has to be choice B. I hope that didn't take over 2 minutes. Number 2, same idea. I notice that everywhere along the horizontal line, y equals 2, I have myself a slope of 0. So I'm going to put y equals 2, and I don't know what this is here. I don't even know if it's defined. Maybe it's undefined. I believe it is. But I'm going to go there at x equals 1, y equals 2, and I have a slope of 0. So x equals 1, y equals 2. So let's see, 4 minus 4. It could be that one that has a slope of 0. That's 0 on the top. I'm going to plug in y equals 2. Can't do it for this one. But x equals 1. Let's see what happens. That's going to give me 3 minus 4 is negative. Negative over 1 is not a slope of 0. It can't be choice B. I'm going to take y equals 2 and plug it in. That's going to give me 2 squared, which is 4. 3 times 4, which is 12. 12 minus 4, which is 8. 8 over 4 is 2. Positive slope, not a slope of 0. It cannot be choice C. I'm going to take y equals 2, x equals 1, and plug it in. 2 minus 2 is 0 over 2. It could be this one. Now I need to choose another point. Well, I'm going to go down here at 1, negative 1. Notice at 1, negative 1 in this quadrant, I have a positive slope. So let's see. At 1, x value, negative 1, y value. So the y value is negative 1. That's going to give me 1 minus minus 2. So that's going to give me negative 2 times negative 1 is positive 2. So that gives me a positive 2 over x value of 1. So that's going to give me a positive slope. Again, it could be choice A. Let me throw 1, negative 1 into the bottom. Choice D. So y is negative 1. Negative 1 minus 2 is negative 3. Over 2, that's a slope of negative. It can't be choice D. It has to be choice A. Let me go about this and solve this and see if I can't match it up with any of the answer choices. So the first thing I want to do is separate the variables. I'm going to kick the 4x dx over to the other side, and then I'm going to divide both sides by y. And that's going to give me, for number 3, 1 over y dy equals 4x square root 2x squared minus 1 dx. Now I'm going to take the integral of both sides. That's what we do with differentials. And the integral of 1 over y is e. Integral of 1 over y is ln. The integral of 1 over y is ln y equals, now over here I'm going to have to do, I think a u sub to take the integral of this. So I'm going to let u equal 2x squared minus 1. Take the derivative of both sides, equals, notice, 4x dx. And that's going to line up with my 4x dx. I'm in the u world now. That's going to give me the integral of square root u du. Integral of square root u, ln y is going to equal 2/3 u to 3 halves. No plus c, because I have to plug in my original u sub. So it's going to give me ln y equals 2/3 2x squared minus 1 to 3 halves plus c. Now what I would like to do is solve for y. So I'm going to base e both sides. Y throwing 1 up here. This is going to give me y equals ce to the 2/3 square root 2x squared minus 1. Squared goes in the bottom, in the bucket. The bottom goes in the bucket, and the cube either goes here, outside, either or. I'm going to put it outside. And that's going to give me choice C. I'm sorry, choice B. Choice B. Possible solution. Going to rewrite it as x dy dx equals negative 2y. I subtracted 2y from both sides. Y prime can be written as dy dx. I'm going to separate the variables. That's going to give me x dy equals negative 2y dx. For multiplying the dx over to that side. Now I'm going to divide both sides by y. And I'm going to divide both sides by x. To give me 1 over y dy equals negative 2 times 1 over x dx. I could have put that negative 2 on top, but I want to integrate both sides. It's just more convenient for me to look at that integral than it is with negative 2 over x. The antiderivative of 1 over y is ln y equals negative 2 ln x plus c. Now, if I have ln x with a negative 2 out front, I can kick that negative 2 up as its exponent. That's a legal move. Now to solve for y, I'm going to base e both sides. E to the ln y is just y equals. Now over here, remember, if I have some item such as e to the x plus c, I can rewrite that as e to the x times e to the c. And e to the c can equal just c. So this is going to give me c e to the x. I'm going to use that idea and rewrite this as c e to the ln x to the negative 2. E ln cancels each other out, so my final general solution is going to be c x to the negative 2. Cx to the negative 2. Cx to the negative 2. Let's see. And here's the tricky part. It says determine a possible solution. So it's going to have to be choice C. I'd like to go with none of these, but C could possibly be 1. Number 5. I want to separate the equation. I'm going to multiply both sides by dx. That's going to give me dy equals cosine squared pi over 4 y dx. Well, the y is over here. I need that on this side. So that's going to give me 1 over this whole monster. Cosine squared pi y over 4 dy equals just the 1 dx. Integrate both sides. That's going to give me, well, I can't really take the integral of that right fast, so I'm going to use a trig identity and rewrite that as secant squared pi over 4 times y dy equals x plus c. Now the integral of that is tangent, but I have this inside, so I'm going to do a little quick u sub for that. I'm going to let u equal pi over 4y. I take the derivative of this side, that's going to give me du equals the derivative of that side is just pi over 4 dx. I'm sorry, dy. So I have du equals pi over 4 dy, and I just want to solve for dy alone. So I'm going to divide both sides by pi over 4, and when I do that, I have to multiply by the reciprocal. That's going to go in front of my new u sub. That's going to give me 4 over pi integral secant squared u du equals x plus c. Antiderivative of secant u is tangent u. So 4 over pi tangent whatever u is equals x plus c. Remember, u equals pi over 4y. Don't forget my initial condition from the original problem was y equals 1 when x equals 0. So for this spot over here, I have a coordinate 0, 1. Where x equals, wherever there's an x, I put a 0. Wherever there's a y, I put a 1. So this is going to give me 4 over pi tangent 1 pi over 4, or just pi over 4, equals, I put a 0 in for x, 0 plus c, or just c. Now pi over 4, when the unit circle for tangent is 1, so that's going to give me 4 over pi equals c. I got to find my general solution, right here, and plug in that value for c, 4 over pi. This is going to give me a nice new equation. 4 over pi, tangent, pi over 4y, equals x plus 4 over pi. Now, my next condition is, when y equals 3, find x. So that's going to be something 3. That's going to give me some value, comma 3. And they want to know the x value. So wherever there's a y, I plug in the 3. Remember, this here was a y. That's a y there. I just left that blank to throw in the 3. So technically, that's going to be 3 pi over 4. 4 pi over tan, 3 pi over 4 equals x plus 4 over pi. And I want to figure out what x equals. So I have all my information. So it's going to be 4 over pi. 3 pi over 4 on the unit circle. Recall is over there. And that's going to be negative root 2 over 2, comma root 2 over 2. And the tangent of that is going to give me negative 1. So tangent of 3 pi over 4 is negative 1. So I'm just going to put the negative out front. Equals x plus 4 over pi. Now I have to solve for x, and I'm going to subtract 4 over pi from both sides. And notice when I subtract those, I get negative 8 over pi. Negative 8 over pi. And that's going to render me choice D. Number 6. I have the differential y prime equals y over 2. So I'm going to rewrite it as dy over dx equals y over 2. I want to separate the dy dx. So I'm going to bounce that over to the right side and divide both sides by y. So this is going to give me 1 over y dy equals 1 over 2 dx. Next step in the process is take the integral of both sides. The antiderivative of 1 over y is ln y equals 1 half x plus c. Now when I get rid of the ln, so I base e both sides. And recall, when I do this with the right side, it's going to give me a nice c out front, but this is just going to simplify to y. E to 1 half x plus c is equal to e to 1 half x times e to c, which is just c, e to 1 half x. Now it gives me an initial condition where x is 0 and y is 80. So the initial condition is 0, 80, and I can use this to solve for c. When x is 0 and y is 80, that's going to give me 80 equals c, e to the 1 half of 0. 1 half of 0 is 0. E to the 0 is 1. So this is going to give me C equals 80. Once I have that, C equals 80, I can plug it back in to the general solution to get a particular solution. 80 e to the 1 half x. Let's see if it matches up with any of them. That's going to give me choice B. Not negative, positive. Number 7. I want to find the particular solution, not the general solution, but first I have to find the general. So that's going to give me dy over dx, re-representation of y prime, equals x over y. I'm going to multiply both sides by dx. This is going to give me multiply both sides by y. This is going to give me y dy equals x dx. And then I take the integral of both sides, and that's going to give me y squared over 2 equals x squared over 2 plus c. I'm going to multiply everything across by 2. This is going to give me y squared equals x squared plus 2c or just c, it doesn't matter. And now, I have an initial condition of 2, 1. That was given up in the heading. Wherever y is 1, I plug it in. Wherever x is 2, I plug that in. 2 squared is 4. So this is going to let me know when I subtract 4 from both sides that c is going to equal negative 3. I'm going to plug that back into this particular, general solution. And this is going to give me y squared equals x squared minus 3. Let me take a look at the multiple choice selection. It cannot be choice A, because there's nothing squared. With that notion, it cannot be choice D, nothing squared. So it's either going to be C or B. Notice if I subtract y squared from both sides, and add C3 to both sides, this would give me x squared minus y squared, x squared minus y squared, equals a positive 3 on the other side. Choice B.